In this video, we're going to be talking about the properties of logarithms, of which there are three that you need to know, and they're in the box below. The first one is the product property, which basically says if you have the log of a product, in this case it's the product of u and v, if you're multiplying two things together in a log, what you can do is separate that product by adding the log base b of u to the log base b of v. So you separate the product through the addition of two separate logs. The quotient property says if you have the log of a quotient, in this case u over v, you can do the log of the top, or log base b of u, minus the log of the bottom, log base b of v. The power property, the last one, is if you have the log of a power. What you can do is take that exponent and bring it out in front of the log. So it's going to be n times the log base b of u, without the exponent n. So let's go ahead and use some of the properties of logarithms in example 1. It says use the fact that log base 3 of 4 is approximately 1.262 and log base 3 of 5 is about 1.465 to approximate each of the following. Now the whole idea is, what we're going to try to do is figure out what log base 3 of 4/5 is utilizing this and this. We need to somehow rewrite the log base 3 of 4/5 so we can apply log base 3 of 4 and log base 3 of 5. Now, as part of the solution here, you can see, since we have a quotient, they're going to separate that quotient using the quotient property. You can do log base 3 of 4 minus the log base 3 of 5. So log of the top minus log of the bottom. What's nice about that is log base 3 of 4, guys, is 1.262. So we just have to do that minus the log base 3 of 5, which we know is 1.465. So 1.465. And if you do the subtraction there, I think you get negative 0.203 if you do that. So we know that the log base 3 of 4/5 is about negative 0.203. Let's do another one. Now this one's not very obvious when you first see it. Log base 3 of 20. You want to figure out a way of rewriting 20 using the 4 and 5. So, this one's maybe a little bit more obvious, but 20 can be rewritten as the product of 4 and 5. Now once you have realized that, now we can use the product property and do log base 3 of just the 4 plus log base 3 of 5. Log base 3 of 4 again is 1.262, and then we're going to add to that the log base 3 of 5, 1.465, which would yield a sum of 2.727. So log base 3 of 20 is about 2.727. Now this last one for C, we have log base 3 of 16. Once again, it'd be nice if we can rewrite 16 using some combination of 4 and 5. Now you might be thinking, well, 16 is 4 times 4, which is absolutely true. I'm going to do the same thing, but write that as 4 squared. So 16, if I write as 4 squared, now you can see I can use that product, or not the product property, the power property. I can bring the power 2 out in front of the log. So it's 2 times the log base 3 of the number 4. Again, that's nice because I know what that value is. It's really just 1.262. So to finish this off, I have to do 2 times 1.262, which if you put that in your calculator, that's about 2.524. So I'm going to write 2.524 for my final answer. One of the things I'd like you to try right now is the checkpoint. Very similar type of problem. You're going to use the fact that log base 5 of 3 is about 0.683 and log base 5 of 6 about 1.113. I'm going to give you a hint for number 1. To do log base 5 of 2, you want to figure out a way of rewriting that number 2 using a combination of the 3 and the 6. And I'll give you a hint. You're going to want to use the quotient property here. And I think you might be able to figure out a way of rewriting 18 using some combination of 3 and 6 for number 2. We'll let you guys try that on your own. Now, moving on to another example, we should be able to, using the properties, do something called expanding a log expression. When you expand, you make larger, right? So if we're expanding, we're going to make it larger. We want to write it as many logs instead of just a single log. So if you look at this problem, we have log base 4 of the quotient x squared over 3y cubed. We assume that x and y are positive, so we don't have to worry about undefined values here. The first thing that I would try to apply is the quotient property, and they have that written right here. So the quotient property would just be log base 4 of the numerator x squared minus log base 4 of the denominator 3y cubed. Now, what would probably be a good idea next, before we do anything else, is you want to separate the product of 3 times the y squared. So I'm going to rewrite log base 4 of x squared. There's nothing I'm going to do yet with that. We will get to that in a second. But I want to first separate this product of 3 times y cubed. So in parentheses, I'm going to rewrite this as log base 4 of 3. Then remember, product property is separating with addition. So it's going to be plus log base 4 of y to the third. And I'll put all that in parentheses. Now what I'm going to use is the power property and bring down the exponents in front. So if I do that, I'm going to have 2 log base 4 of x minus, if I distribute the negative, minus log base 4 of 3. And if I distribute the negative here, I'm going to have minus. Now notice over here there was an exponent of 3. I can bring the 3 down in front. So it's going to be minus 3 log base 4 of y. Now, to simplify, I'm going to see if there's any like terms. Like terms means I have to have exactly the same log with same base and number inside it. Now, I don't see any like logs. This is log base 4 of x. This is log base 4 of y. I can't add those. So really, this is my final answer. I've separated the single log and expanded it into the sum, or difference in this case, of 3 other logs. The opposite is called condensing. When you condense something, you make it smaller. So here we're going to condense the sum of 3 logs and try to make them into 1 log. My hint to you, and they have it written here, always start, if possible, using the power property. Power property is going to be the first thing you do here, whereas when you do the expanding, this should always be done last. The power property is done at the very, very end. You want to apply quotient and product properties first, if that's at all possible. So here, I'm going to do the power property first, and the way you know you can use the power property is if you have a coefficient in front of the log. That number, any of those numbers in front of the logs, can be rewritten as the exponents. So since the log of 3 doesn't have any number other than a 1 in front, I don't have to mess with that, but I can take this 3 and rewrite it as an exponent. So it's going to be plus the log of 2 to the third, and there is no number in front here, so it's just going to be minus log 6. Now what I'm going to use is the product property on these two guys. Since we're adding, that means I'm going to multiply in the same log 3 times this 2, and this is supposed to be a multiplication sign, times the 2 cubed, which is 8. So I'm going to write that as log of 3 times 8, and then they just copy down minus log 6. Now because we're subtracting 2 logs, we're going to use the quotient property. So remember, quotient property is log of the first thing in the numerator, so it's going to be log of, I can rewrite that as probably 24. So 3 times 8 is log of 24 over the log of 6, so that's going to be 6 in the denominator, which is just the log, 24 divided by 6 being just the log of 4. That's an example of condensing. What I'd like you guys to try here is expanding first. Now remember, when you expand, I'm going to give you just a little bit of a hint here. I would definitely try to use quotient property first, So try to separate the quotient, then use the product property next, and then always finish with the power property in that order when you're expanding. However, when you condense, let's take a look at this guy. When you condense, the first thing I would do is look for any power property, which I already know, I got a power there because there's a coefficient in front, and I have a power there. And then finish off by using either the product property or the quotient property, whatever makes sense to use. So go ahead and try that. To finish off this video, we're going to take a look at a special change of base formula. The change of base formula basically will let you rewrite the log base whatever into a different base of your choosing. So here, if you have log base c of u and you don't like that base c and you want to change that base, you can do it just by simply doing the quotient of log base b, whatever b is, a base of your choosing, of the number u over log base b, whatever that base is you like, of the original base c. In particular, if you have log base c of u, you can do the common log of u over the common log of the original base c. Or you can use natural logs. You could do the ln of u over the ln of the original base c. So that's supposed to be a c there, over the ln of c. So that looks very confusing right now, and it really doesn't need to be. Let's do a couple of examples. In example 4, it says change log base 5 of 6 or evaluate it using common and natural logs. Let's just remind ourselves what we're really trying to figure out here. It's asking for what is the log base 5 of 6, right? Of a 6. What's that equal to? In exponential form, we're asking 5 to what power is 6, which is a number that's not very obvious. It's a little bit bigger than 1 probably if we have to guess. In order to do this using our calculators, we have to use the change of base formula. So what I'm going to do is, using common logs, I'm going to do just the common log of 6 over the common log of the original base 5. Now when you use your calculator, you have to be careful how you type that in. Make sure you enclose, when you type in that log, you got to put log of 6, close the parentheses, and then type in log of 5 and close the parentheses. And you'll get approximately 1.11. Please try that now if you didn't, and make sure you're getting that same value. If you use natural logs, all you have to do is the ln of 6 over the ln of 5, and you have an ln key on your calculator. Likewise, if you type that into your calculator, you should get about 1.11. Doesn't matter which one you choose, they both will work. Make sure you try evaluating log base 7 of 9 using natural logs for your final little self-quiz question here. Thanks for watching.